We're going to talk about end behavior of rational functions. And the end behavior of a rational function is similar yet more complicated than that of polynomials. And it's easiest to study if we break it down into cases. So the first case that I want to look at is that the degree in the numerator is less than the degree in the denominator. So the degree in the top of the fraction is less than the degree in the bottom of the fraction. For instance, our first function, f of x equals 8x divided by 5x squared. If we type that into our calculator, we get this picture right there. And even before we look at a couple of more of these examples, if you look down below at your box, it says what happens to the y values as x approaches negative infinity or x approaches infinity. So in other words, let's go to the positive direction because sometimes that's easier for people to understand. As we go towards the right on the graph, what is that blue part of the graph? What's that approaching? Well, hard to see, and it is the first example. It's getting closer and closer and closer and closer and closer and closer and closer to the x-axis. So it looks like it's really approaching 0. But if we come over here and we draw this in, it was something like this, and the screen a moment ago was clearly much better. If we try the next graph, like I said, does not want to cooperate. Turn that one on. Turn this one off. We look at the second one. Looks like this. So we can draw a rough sketch of that. And again, as you're drawing this picture, and it really is a rough sketch, as x approaches infinity, as we go to the right in the graph, where is this graph going? And hopefully you're thinking that it's getting closer and closer and closer to the x-axis, which means that it's getting closer and closer and closer to 0. Or we try one more. Hopefully it won't take me as long. Oh, gosh. And in this one in particular, it looks like the graph is on the y-axis, on the x-axis, but it really isn't. And one of the ways that we can tell is if we go to the table, and what we see is we see these values, like negative 9e to the negative 4. That means 0.0009. Or 0.0002, and they're negative, sorry. Negative 0.00007. It's in scientific notation. But we're getting closer and closer with more and more zeros in front of there to zeros. Again, our picture looks like this. in this in rough picture there. But ultimately what happens when the degree of the numerator is less than the degree of the denominator, we sometimes call it bottom heavy, what actually happens in a graph is that as x approaches infinity, by the way this arrow means approaches, y is going to approach 0. And as x approaches positive infinity, y still approaches 0. Now remember, we're going to spend the week on this, and it's a little bit different from how we've approached things before. But here's a couple more, the second case here. And rather than spending all of my time drawing them in, I have the pictures down here below. But the first one, it says, well, by the way, it's the degree in the denominator is equal to the degree in the numerator. So same degree on the top of the fraction and the bottom of the fraction. Our first graph, what color is it? Oh, they're all blue this time. Our first graph looks like that. And I'm going to jump over here to the last one for a moment. If we type that one in, it looks like this when I type it in. And again, very rough sketches. It's the middle graph that's a little bit weird. But it looks something like this. But what I want to particularly look at here on our tables for these graphs is, where is y going? And in fact, what I wrote on my paper when I did this is, I said, well, as x approaches infinity, what's y approaching? And in fact, in this one, it's not even approaching. It's there. And you can go back and look on the screen here in the calculator if that wacky stuff doesn't happen to you like it's happening to me. But if there's the picture. Look at the table. As x, as we go down our x table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, what's happening to y every single time here after 0? It's always going to 3. If you look over here as x goes towards negative infinity, ooh, don't do that, don't do that. As x goes towards negative infinity, sorry, my calculator is being super duper wacky. Stop. But both times, what we see is whether x is going to infinity or x is going to negative infinity, our y value is going to 3. Now while you're writing that down, I'll try to get this next one on the calculator. And it's actually the last picture on your graph of that page. It's the one to the far. Can I turn it on? to the far right on your graph, which looks like this picture. If we go to the table, what we're looking at is what's happening to the y values as we go to the right on the graph, or we go to the left on the graph. So we go second in table, and I want to scoot back up, but we can already see as we're going to the right, because my table was not in the place where I wanted it to be, we started at negative 0.5, and then we went to negative 1.953 and negative 1.994 and then negative 1.999. We're actually getting closer and closer and closer to this value of negative 2. And if you go the other direction, negative 3.5, negative 2.047, as we scroll through, eventually we get to the place on our screen where it's always approaching negative 2. So when we look over here to the far right, we can say that as x approaches infinity, y is approaching negative 2. And as x approaches negative infinity, y is still approaching negative 2. And if we had a little bit more time here for this middle one, I'm running out of time, so as x approaches infinity, we want to know what happens to y. Well, in this case, if we started scrolling through, we'd find out that y eventually approaches 3. And as x approaches negative infinity, y is really still approaching 3. But we didn't have time to scroll through the screen, which I find is what's the most helpful part. But if we go back and look at this problem here, if you look at the equation, the first equation up here to the left, what y approached was 3. 3 divided by 1. And what y approached in our second graph is 3 divided by 1. And what y approached in our third graph was negative 2, negative 4 divided by 2. So in terms of the table here, what happens here as x approaches negative infinity, y approaches a over b. So now I'm going to skip case 3 and jump over here to the end here, because this is a summary here. The first situation that we did is we did bottom heavy. So the numerator degree was smaller than the denominator. The top degree was smaller than the bottom degree. And what happens is we came up with y was approaching 0. In the second case that we just came up with, we came up with the fact that the horizontal was approaching some value of a over b, but the a and the b are coming from the leading coefficient in front of the highest degree on the top of the fraction, and the leading coefficient on the bottom, which is the number in front of the highest degree term in the bottom of the fraction. And the third case that we didn't look at has what's called an oblique or a slant asymptote, so there's a diagonal to it. It would be in the form of y equals mx plus b, and in order to get that situation, the top of the fraction degree has to be 1 degree greater than the bottom of the degree. So bottom heavy, y equals 0. Top heavy, going to have y equals mx plus b, and then when they're the same degree, we're going to get y equals a over b. So to finish here, if we look at a couple of examples, what we're looking at again are the degrees. In this first case, we have the square on top for our degree, and we have to the first power on bottom. So what that means is that this problem is top heavy. And when it's top heavy, we do not have a horizontal asymptote. If we look back at our chart, top heavy means that we have an oblique asymptote, no horizontal, because the direction tells us that if we have a horizontal, we want to write the equation for it. Problem number 2, or the B of x. Look at the degree. There's a 3 in the top degree. There's a 3 in the bottom degree. So what we have is we have the same degree on the top and the bottom. So let's go back and look at our chart. Same degree says that we are going to have a horizontal asymptote at y equals a over b. So HA, abbreviation for horizontal asymptote, and it's going to be at y equals, the number in front of this x cubed is 7 from the top, the number in front of the x cubed on the bottom is a -2. Y equals -7/2 is a horizontal asymptote. If we look at C of x, again, it's all about the degrees. We have a degree of 3 on top. We have a degree of 4 on bottom. This one is bottom heavy. So we go back and look at our chart, and bottom heavy tells us that we're going to have a horizontal asymptote at y equals 0. Lastly, the degree on top is a 1. The degree on bottom is a 3. This one is also bottom heavy, which means that we will have a horizontal asymptote at y equals 0.
November 14th with my brother and I, and